Good evening, everybody. My name is Father Benedict O'Kinsella. I'm the president of the Athenaeum, and I just want to welcome you and go through a number of housekeeping details before we begin. For those who may need restrooms during the evening, over here at the back, the door over here on the back, on the left, is the way to the restrooms. This talk will be available on the St. James Project website in a couple of days, so if you want to listen again, please go there. Please notice where the emergency exits are. I know it's not an airplane, but nevertheless, okay, the front entrance here, and over here, this exit here. There's also an exit here, but it really doesn't lead anywhere except into a garden, and you really don't want to go into that garden, okay, because there's a big German Shepherd in there. So if there is an emergency, go that way or that way. We have also these information cards that we would like you to fill out before you leave, which tells us something about the audience that's here this evening, and also gives us some idea of the type of things that you might be interested in having speakers come and give lectures on. So, or for receiving more information, these cards will help us. So if you can, please fill those out before you leave. I'd like now to invite Dr. Nati to introduce our speaker for this evening.
I'm Dr. Tobias Nathi. I'm the director of the St. James Project, and this is just one event that we do. We put on lectures. We partner with various groups and affiliates. If you have a community, a group, or an apostolate, and you want to have an Athenaeum speaker, for example, an Athenaeum faculty member, you want to put something on here, perhaps we could help you out, so you can always get in touch with me. And this particular event is co-sponsored by Covington Latin High School. Mo Waltering, the headmaster, is here. Some various faculty members here as well. And we're really excited to have Dr. Stephen Barr. Just a quick note, after the talk, Dr. Barr will be selling his books for $20 a piece, cash or check. And that's also where you can find the information sheets to fill out what you might want to hear in the future regarding lectures. So Stephen M. Barr is a professor of physics at the University of Delaware. He received his PhD from Princeton University in 1978. He does research in theoretical particle physics with emphasis primarily on grand unified theories and the cosmology of the early universe. He also writes and lectures extensively on the relation of science and religion. Many of his articles and reviews have appeared in First Things, on whose advisory council he serves. He's the author of the book Modern Physics and Ancient Faith, which is what we have. Also, A Student's Guide to Natural Science, and Science and Religion, The Myth of Conflict. He has served on the board of the Fellowship of Catholic Scholars and was elected in 2010 to the Academy of Catholic Theology. He and his wife Kathleen have 5 children and live in Delaware. We're going to have his talk and then afterwards have at least 15 minutes for Q&A. So we'll be happy to take your questions and comments then. Okay, without further ado, Dr. Stephen Barr.
Thank you, Father, and thank you, Dr. Nathi. I want to emphasize, the money, if you buy the book, I'll donate it to the seminary. I'm not trying to, I don't have mercenary motives here. Before I begin, I just want to ask, how many people recognize the fellow on the right? Okay. How many people recognize the clerical fellow on the left? Not as many. Okay. Well, that's good. It's bad and it's good, because by the end of this talk, you're going to know who that gentleman is. We often hear, the title of my talk is Science and Religion, the Myth of Conflict. Can you hear me? No. Should I put this higher up? Can you hear me now? Is that okay? Maybe if I close turn on. Is it on? How's that? Is that all right? Okay, I'll speak loud. Tell me if I'm speaking too loud or too soft. We often hear of a conflict between science and religion. Is there one? The answer depends, of course, on what religion one is talking about. Certainly, many animistic and primitive religions conflict with science, and some forms of Christianity and Judaism that interpret the Bible in a narrowly literalistic fashion also do. As a Catholic, I'm naturally most concerned with the Catholic faith, as I'm sure most of you are. But everything I will say in this talk would apply equally well, I think, to the historical mainstream of Protestantism and Judaism, and very likely to some other monotheistic religions as well. I maintain that there really is no conflict between religion, so understood, and science. What there is, and long has been, is a conflict between religion and scientific materialism. Materialism is not science, although it often wraps itself in the mantle of science and is called, even by its opponents, scientific materialism. It is rather a philosophical doctrine. It is a very simple doctrine, and this simplicity accounts for much of its appeal. It says that the ultimate reality is matter, and therefore everything that happens and everything that exists can be explained by the laws of physics and blind chance. However, there is more to scientific materialism than this. It's not just a philosophical opinion. As embraced by some people, it is a passionately held ideology that sees itself as having a saving mission. That mission is to free men's minds from superstition in all its forms, but especially in the form of religion. Religion thus plays, for some materialists, the role of a needed enemy, the struggle against which contributes to the larger meaning and purpose of their lives. It is necessary to their worldview, therefore, that there be a conflict between science and religion. Scientific materialists have a well-developed critique of religion, which has at least three strands: historical, philosophical, and scientific. The philosophical claim is that there's an inherent contradiction between the scientific and religious outlooks. Science is based on reason and evidence, whereas religion is said to be irrational because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen, and therefore, for which supposedly there is no evidence. Science is based on natural explanations and natural laws, whereas religion is based on miracles and the supernatural. Many materialists see religion as a matter of myth and magic, and therefore pure superstition, which is the very antithesis of a rational scientific outlook. The historical claim is that religious believers and institutions have been hostile to science and tried to suppress it. This is powerfully symbolized in the eyes of many people by the Catholic Church's treatment of Galileo. And this impression is constantly reinforced in the public mind by the battles waged against evolution by biblical literalists. The scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined traditional Christian beliefs about the universe and mankind's place in it. As the story is often told, science has dealt one blow after another to the religious conception of the world. Copernicus showed that man is not at the center of the universe. Newton showed that the world is governed by blind and impersonal forces. Modern astronomy showed how small and insignificant we are compared to the cosmos as a whole. Darwin, they say, showed that humans differ only in degree from the lower animals. Three strands in turn. First, the philosophical. The philosophical critique is largely based on crude by that the rejection of the idea of a natural order. Indeed, scholars tell us that the book of Genesis was in part a polemic against pagan supernaturalism and superstition. When Genesis said the sun and moon were merely lamps placed by God in the heavens to light the day and the night, it was attacking the paganism that worshipped the sun and moon. When it said that man was made in the image of God and was to exercise dominion over the animals, would that be a better? Exercise dominion over the animals. Genesis was, among other things, attacking the paganism in which men worshipped and bowed down to animals, or gods made in the image of animals. In paganism, the world was imbued with occult forces and populated by numerous deities, gods of the ocean and the forest, gods of the lightning and of the sun and of the wind and sex and fertility and so on. But Jews and Christians taught that there was only one God who was to be sought not within nature, not within its phenomena and forces, but a God who was outside of nature and was indeed the author of nature. In this way, biblical religion desacralized and depersonalized the physical universe and made it indeed into a natural world, and thus helped to clear the ground for the much later emergence of science. In the biblical religions then taught that there is a natural order which comes from God. What characterizes this natural order and reflects the rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage from the famous letter of Clement to the Corinthians, written about 97 A.D. Clement was a bishop of Rome and traditionally listed as the fourth in the list of popes. I guess I used these arrows. Okay, hold on a second. There we go. So this is an excerpt from the letter of Clement to the Corinthians. The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and the starry choirs roll on in harmony at his command, none swerving from its appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the Christian apologist Minucius Felix, writing around 200 A.D. If upon entering some home you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too, in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe, more beautiful than the stars themselves and the various parts of the whole world. So it was not the supernatural or the miraculous departures from the order of nature, but the order of nature itself and its lawfulness that were seen as pointing to its creator. The ancient argument was that if there is a law, there must be a lawgiver. God was the lawgiver not only to Israel, but to the cosmos itself. God says in Jeremiah chapter 33, "When I have no covenant with day and night and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." Psalm 148 tells of the sun, the moon, the stars, and the heavens obeying a divinely given law that will not pass away. The idea of God as a rational lawgiver very likely helped give birth to modern science and to its idea of laws of nature, as even some atheists at times concede. For example, the eminent biologist E.O. Wilson. Whoops. Let me see if I can get this The eminent biologist, E.O. Wilson suggested the following as the reason that Chinese civilization did not produce a Newton or a Descartes. He wrote, quote, Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed in their universe. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them. And the well-known cosmologist, Andre Linde, has suggested that the notion of a universe governed by, quote, a single law in all its parts, unquote, is historically rooted in monotheism. And he says this despite the fact that he is himself an atheist. Christianity does, of course, teach that there are supernatural realities, such as divine grace, that have effects in the world. But the word supernatural, which means above the natural, would make no sense unless there were a natural order to begin with. And the concept of miracles, which are extraordinary events that go beyond what is naturally possible, presupposes that there is a natural order that determines what is naturally possible and what is not. There's no logical contradiction between the idea of miracles and the idea of a lawful universe, for the same lawgiver who established the laws of nature can also suspend them. There's much confusion today, even among believers, about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition. So that if something has a natural explanation, then God has nothing to do with it. And conversely, if God is the cause of something, then it must be supernatural. Many, therefore, look for evidence of God only in what is outside the course of nature, or inexplicable by science. That is, in the gaps in our scientific understanding. Hence the expression, the God of the gaps. And atheists think that by closing those gaps, they will leave no place for God to hide. The traditional Christian and Jewish view was quite different. If God, as creator of the natural world, established its laws and gave things their natural powers, then his existence is evident in nature itself and its ordinary processes, whose power and working reflect God's own power and wisdom. This was the message of the following passage from the Book of Wisdom, a Jewish work of about 100 BC, which is recognized as part of the Bible by Catholics and Eastern Orthodox Christians. For all people, by the way, this passage from the Book of Wisdom I think is very interesting because I think it could be said to be the only passage in the Bible which is addressed to scientists. And the scientists it was addressed to were the philosopher-scientists of ancient Greece. So this was a Jewish answer to the challenge posed by ancient Greek philosophy and science. For all people who were ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists. Nor did they recognize the artisan while paying heed to his works. But they supposed that either fire or wind, or swift air, or the circle of the stars, or turbulent water, or the luminaries of heaven were the gods that ruled the world. If through delight in the beauty of these things people assumed them to be gods, let them know how much better than these is their Lord, for the author of beauty created them. And if people were amazed at their power and working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their Creator. Yet, these people are little to be blamed, for perhaps they go astray while seeking God and desiring to find him. For while they live among his works, they keep searching, and they trust in what they see because the things that are seen are beautiful. Yet again, not even they are to be excused. For if they had the power to know so much that they could investigate the world, how did they fail to find sooner the Lord of these things? Now notice that the evidence of God to which this passage points consists of phenomena that are perfectly natural: fire, wind, swift air, the circle of the stars, turbulent water, and the luminaries of heaven, that is, the stars, planets, sun, and moon. By the way, some of you will hear echoes of this. This passage is clearly echoed by St. Paul in the first chapter of Romans, when he talks about the pagans being without excuse because they can know God from the things that are made. Very clearly, he was echoing this passage from medieval. So, again, it is in the natural order that we primarily see evidence of the existence of God. Medieval theologians distinguished two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through the operation of natural causes and processes. It has always been the Christian view that God ordinarily acts in the latter way. In the words of the 16th and 17th century Catholic theologian Suarez, quote, God does not interfere directly with the natural order, where natural causes suffice to produce the intended effect. This principle was important for the founding of science, for it implied that when confronted by some puzzling event or new phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every unusual or strange event. But this was strongly criticized by the great medieval theologian and scientist Nicholas Oren. In explaining the marvels of nature, he said, quote, there is no reason to take recourse to the heavens, or to demons, or to our glorious God, as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us. Unquote. Another great medieval theologian and scientist, Jean Buridan, said that when confronted by new phenomena, we should seek, quote, appropriate natural causes. That's why the Catholic Church does not declare a miracle to be worthy of belief until it has excluded the likelihood of natural explanations. This brings us to the all-important theological distinction between primary and secondary causality. I think the failure to grasp this distinction is one of the main reasons that people see a conflict between science and religion. This distinction can be explained using a simple analogy. Consider a play, such as Hamlet. In Hamlet, the character Hamlet kills Polonius by stabbing him through a curtain. Now ask yourself this question. Did Polonius die because Hamlet stabbed him? Or did Polonius die because Shakespeare wrote the play that way? Okay. Obviously, it's a silly question. For both are causes, but at different levels. Hamlet is the cause of Polonius' death within the play, within the plot of the play. He is the horizontal cause, or what theologians would call the secondary cause, whereas Shakespeare is the vertical or primary cause of the whole play and its entire plot and all its characters and all of its events, including, of course, Polonius' death. There's no competition or conflict between these two levels of causality. By analogy, the natural causes within the universe, which are studied by scientists and other people, are horizontal or secondary causes, while God, as the author of nature, is the vertical or primary cause. The analogy makes clear just how silly it is to treat evolution and creation as alternatives, as both fundamentalists and atheists do. Did this species of animal arise by natural processes, or because God wrote nature's script that way? Of course, both. This is why the Catholic Church has never condemned or opposed evolution. This also makes clear why scientific materialists are wrong to think that believers in God do so without evidence. For materialists, evidence means either directly observing something with our senses or inferring that something exists as a natural cause of what we observe. As we observe a compass needle move, and we infer that there's a magnetic field. Obviously, God cannot be seen in these ways, for he is neither a part of nature which can be sensed, nor a natural cause. And yet God is a cause, the ultimate cause. He's not a cause within nature. He is the cause of nature. Thus, nature gives evidence of God in the same way a novel gives evidence of its author, even if the author does not make an appearance within the book. Now let's turn to the materialist historical critique of religion. The idea that Christianity and the Catholic Church in particular opposed science and tried to hold it back is called by historians the conflict thesis. It has been completely discredited by historians of science. It is a myth, pure and simple, whose roots lie in the Enlightenment and the contempt many of its thinkers had for revealed religion. Its growth was aided in Catholic countries by anti-clericalism and in Protestant countries by anti-Catholic prejudice. The conflict thesis was popularized by two enormously influential books written in the late 19th century. The History of the Conflict Between Science and Religion by John William Draper, and A History of the Warfare of Science with Theology in Christendom by Andrew Dixon White, who, by the way, was the first president of Cornell University. These two books are dismissed by scholars today as full of errors of fact and interpretation and historically worthless. Yet, the myths that they generated are still in circulation today. One eminent historian calls Draper's book a thinly disguised anti-Catholic rant. The scientific revolution which took place in the 17th century and gave rise to modern science did not occur in opposition to revealed religion. In fact, most of its great figures were devout Christians. Copernicus, whose work sparked the revolution, was an official of the Catholic Church. Johannes Kepler, famous for his 3 laws of planetary motion, was a devout Lutheran and announced the discovery of one of his laws with the words, "I thank thee, Lord God, our Creator, that thou hast allowed me to see the beauty in thy work of creation." Galileo remained a devout Catholic throughout his life. When he was too old and unable to walk, he had himself carried to Mass. Descartes, whose work in mathematics was foundational for modern science, believed in God and the reality of the spiritual soul, and there is no reason to doubt that he was, as he said, a sincere Catholic. Blaise Pascal was not only a mathematician and physicist of genius, but a Catholic mystic. Robert Boyle, the first modern chemist, often regarded as the father of chemistry, left a large sum of money to endow a series of lectures whose purpose was to combat the ideas of notorious infidels, which in those days meant atheists. And Isaac Newton, the greatest of them all, spent as much time on theological and scripture studies as he did on science. All of these great founders of modern science saw their work as showing the beauty of God's creation rather than as supporting atheism. And this was true long beyond the 17th century. The two greatest physicists of the 19th century, Michael Faraday and James Clerk Maxwell, were deeply devout Protestants, even by the standards of their time. Moreover, the scientific revolution did not spring out of thin air. Its foundations were laid in the universities of medieval Europe, as has been strongly emphasized by the distinguished historian of science, Edward Grant. It was the scientific community and the scientific public these universities created were the soil in which the seeds of the scientific revolution germinated. A little-known fact that dramatically illustrates the positive role that the Catholic Church has played in the development of science is the large number of Catholic priests who made major discoveries. I have only time to mention a few of the most outstanding. I'm going to skip, for reasons of time, the examples from the Middle Ages. St. Albert the Great, Robert Grosseteste, Thomas Bradwardine, Nicholas Arem, and I left out, I could also say, Roger Bacon, John Buragon. There are many examples, and some of them are very impressive figures scientifically. So let me skip to the 17th century, the century of the scientific revolution. In the 17th century, there were six, at least, I'm only going to mention six very important priest scientists. Niels Stenson, Marin Mersenne, Christoph Scheiner, Giambattista Riccioli, Francesco Grimaldi, Benedetto Castelli, and Bonaventura Cavalieri. Stenson, who's on this slide, also known as Nicholas Steno, was actually born in Denmark. He was a Lutheran who, as an adult, converted to Catholicism, eventually became a priest, and eventually was made a bishop. And apparently, as a bishop, he was known for his strict asceticism and his concern for the poor. And John Paul II beatified him in 1981, I believe. So it's blessed, I should say, blessed Nicholas Steno. Stenson was considered the greatest anatomist of his time. And he made fundamental discoveries about animal and human anatomy. Several parts of the human body are named after him. Stenson's vein, Stenson's duct, and Stenson's foramina. I don't know what a foramina is, but one of them is named after Stenson, apparently. But his greatest contribution was to geology. He came up with the correct theory of sedimentary rock. He was the first person to understand that sedimentary rocks had originally been underwater, that they had been formed by the deposition of sediment, that the deeper layers of sedimentary rock were therefore reflecting conditions on Earth in older times, in more ancient times. He also was the first person to come up with a theory of fossils. And so actually he was honored by Google. Name appears first. So he could be considered the father of the science of geology. Marin Mersenne, a Mennonite friar, is considered the founder of the science of acoustics for fundamental discoveries in the theory of sound and vibrations. His religious house became a meeting place of famous scientists, and his voluminous correspondence with other scientists was an important means by which scientists of that time learned of each other's works. Dictionary of Scientific Biography calls him one of the architects of the European scientific community. He also did important work on designing telescopes. He did work in mathematics. Important figure. The next three people I'll mention were all Jesuit astronomers. The Jesuit order has a remarkable, glorious history in astronomical research. The very calendar we use today, the Gregorian calendar, was developed by a Jesuit astronomer named Claudius. So Scheiner, a Jesuit astronomer, shown here in his observatory, was one of the co-discoverers, one of several people who simultaneously at the same time discovered sunspots, or at least discovered them with telescopes. And here's actually a diagram from his magnum opus, his great work on sunspots. And you can see that he's plotting the path of a sunspot across the face of the sun on successive days. And there's a gap. The gap is a cloudy day where he wasn't able to make observation. And from observations like this, by the way, his data on sunspots is still useful to scientists today. But from his observations, he was able to show that the sun was rotating about an axis that's tilted with respect to the ecliptic plane. Another Jesuit astronomer, Riccioli, did many things. He developed precise ways of measuring time in experiments. He discovered the first binary star, or double star. He and Grimaldi made the first maps of the moon's surface. I should mention that it is a tradition, because of the great history of Jesuit astronomy, there's a tradition of naming craters of the moon after Jesuits. And I believe about 24 of the moon's craters are named after Jesuit astronomers, including one of the largest, which is named after the next person, Grimaldi. I don't know how many of you studied physics, but if you study physics at the college or graduate level, you'll know that diffraction, the phenomenon of diffraction, is hugely important. For example, if you were to take a freshman physics course, the entire chapter of your textbook is about diffraction. Diffraction was discovered by Grimaldi in the 1600s. What it shows is that light is a wave. We now know in the 21st century, but since the 20th century, we know that all matter, everything is made up of waves. And so the phenomenon of diffraction is important in every branch of physics. I've shown pictures from the internet of some diffraction phenomena. The one at the top, the colored bands that you see on DVDs and CDs are diffraction phenomena. And so every time you see those colored bands, think of Father Francesco Grimaldi, who discovered this, not those bands, he discovered diffraction. Castelli, Benedetto Castelli, was a Benedictine priest. He is considered by some the founder of hydraulics. He was a pupil of Galileo and a teacher of two very important figures, Cavalieri and Torricelli. Cavalieri, well, Torricelli is very well known in physics for his work on, he invented the barometer. He's the first person to understand the origin, understand the phenomenon of wind. There's a unit of gas pressure named after him, the torr. But anyway, he was not a priest, so I don't show a picture of him. But the other student of Castelli, Cavalieri, was a priest, and he made important contributions to the development of integral calculus. Now, as you know, calculus, is people who invented calculus or discovered calculus were Isaac Newton and Leibniz. And here's a quote from Leibniz himself, paying tribute to the contributions of Cavalieri and Torricelli in the development of calculus. He said that Cavalieri and Torricelli performed a yeoman's task, and others, and Leibniz himself, progressed even farther using their work. In the 18th century, there's Lazzaro Spallanzani, who was considered one of the top biologists of the 18th century. He made many contributions to biology that are too numerous to mention. One thing that he did was disprove the idea called spontaneous generation. Everybody knows that Louis Pasteur disproved spontaneous generation, but actually, 100 years earlier, Lazzaro Spallanzani did a series of experiments disproving it. Pasteur built upon the work of Spallanzani, knew about it, and built upon his earlier work. There's also René Just Oï, who is considered the founder of crystallography, and here's a painting of him holding a crystal and some calipers. There was Giuseppe Piazzi, who was the head of the Palermo Observatory. And among his various contributions to astronomy is that he discovered the first asteroid, which he named Ceres. And here's a picture from the Hubble Space Telescope of Ceres. There was Angelo Secchi, an even greater figure in astronomy. As any astrophysicist will tell you, Secchi is considered one of the founders of modern astrophysics. He was a Jesuit. He pioneered the use of spectroscopy to study stars and the sun. And he developed a classification of stars based on their spectra, which is the basis of the classification of stars that is still used today. And one of the symbols, a very nice symbol of the harmony between faith and science, is the fact that Secchi did some of his epoch-making work, research, using an observatory that he had placed on the top of the Church of Sant'Ignazio in Rome. Now, the church, I suggest if you're in Rome and you go visit Sant'Ignazio, it has a very beautiful fresco. It's a spectacular fresco. It's right near the Piazza Navona and the Pantheon. Unfortunately, the observatory used by Secchi is not still on the roof, but here's a picture of when it was. Bernard Bolzano was a Czech priest and helped put modern calculus and modern mathematics on a rigorous foundation. He was a very important figure in what's called analysis, the branch of mathematics called real analysis. If you study advanced math, you will probably hear about the Bolzano-Weierstrass theorem, the Bolzano function, and so on. And here is a statement from the Stanford Encyclopedia of Philosophy. It says he was an outstanding mathematician and possibly the greatest logician in the time between Leibniz and Frege. And then, of course, everybody knows about Gregor Mendel, the founder of genetics, an Augustinian priest. A priest at the University of Notre Dame, Julius Newland, was a chemistry professor who did work that helped develop the first artificial rubber neoprene. And now we come to the fellow that I showed you at the beginning of the talk. Georges Lemaitre was a Belgian priest and theoretical physicist who is considered the founder of the Big Bang Theory. How many people know that? Okay. The Big Bang Theory, the pillar, the central idea in modern cosmology, was proposed and developed by Georges Lemaitre, based upon Einstein's theory of gravity and upon observations that were taking place in the 1920s that showed the universe was expanding. Because Lemaitre tied that all together and developed the Big Bang Theory. What a record of achievement. It's a glorious record. Professor Lawrence Principe of Johns Hopkins University, who is both a chemist and a noted historian of science, has written, quote, "The Catholic Church has been probably the largest single and longest-term patron of science in history." The rest of my lecture will deal with the third strand of materialist critique of religion, the notion that many of the greatest discoveries of modern science have undermined or debunked the traditional Christian and Jewish view of the universe, of man, and of man's place in the universe. As things stood 100 years ago, this view had some plausibility. But much has changed since then. There have been several major discoveries or developments, especially in physics, that seem more consonant with the Christian and Jewish conception of the universe and of man than with the materialists. I'd like to discuss 5 of them, if I have time. In each case, I'll mention earlier discoveries that had seemed to favor the materialist view, atheist. And then the more recent discovery or development, it points the other way. The first has to do with the structure of the cosmos. We all have heard how Copernicus overturned the religious picture by showing that the Earth is just a tiny speck lost in the vastness of space. Actually, however, the idea and the farther from it things were, the more noble and exalted things became. There was one idea about cosmology that did enter Western thought from biblical revelation. It was not about space and whether it had a center. It was about time and whether it had a beginning. The pagan thinkers of antiquity, including Aristotle, conceived of the universe as having had no beginning. Modern atheists have also tended to prefer this idea. And until about 100 years ago, almost every indication from science seemed to support it. Physicists discovered that the amount of energy never changes. That it cannot, as you probably learned in school, energy cannot be created or destroyed. Chemists found that the number of atoms never changes in chemical reactions. In Newtonian physics, time extended infinitely into past and future, just as space extended infinitely in all directions. Almost everything suggested that matter, energy, space, and time had always existed and always would. The idea of a beginning came to be seen as outdated religious mythology. The Nobel Prize-winning chemist Svante Arrhenius said in 1911, quote, "The opinion that something can come from nothing is at variance with the present-day state of science, according to which matter is immutable," unquote. The Nobel Prize-winning physicist Walter Nernst declared, quote, "To deny the infinite duration of time would be to betray the very foundations of science." But in 1916, Einstein proposed his theory of gravity, called general relativity, and everything changed. In the 1920s, the Belgian theoretical physicist Georges Lemaitre, who was also a Catholic priest, realized the equations of Einstein's theory could describe a universe whose space was expanding. Combining this with the observation by astronomers that distant galaxies were receding from us, Lemaitre proposed what is now called the Big Bang theory. It took a long while to gain acceptance, partly because of philosophical prejudice against the idea of a beginning, partly also for good scientific reasons. But in time, the evidence grew overwhelming that the hypothesized Big Bang did indeed occur about 14 billion years ago. In the standard Big Bang theory, everything began at that point. Matter, space, and time itself. It is possible that something preceded the Big Bang, and that it wasn't the absolute beginning of the universe. There are various speculative theories, models that postulate that. But in those models, the Big Bang was only the beginning of some phase or era of the universe's history. There are, however, very strong theoretical reasons to think that the universe did have an absolute beginning, a finite time ago, if not at the Big Bang, and at some earlier point. So science now strongly supports an idea that came from biblical revelation and was dismissed both by the pagans of antiquity and modern materialists, and for a long time seemed contrary to science. The second development I'll speak about has to do with evidence of design in nature. Religious believers have always seen such evidence: the starry heavens, the forms of living things, and the other wonders of nature were seen as being fashioned by the hand of God. Modern science seemed, however, to undercut this idea by showing that they were the result of mechanisms that depended upon a combination of impersonal laws and blind chance. Whereas Genesis spoke of God placing the sun and moon in the firmament, astrophysics showed that they condensed from swirling clouds of gas and dust under the attraction of gravitational forces. Darwin showed how the intricate structures of living things could arise from natural selection acting upon random mutations. When Napoleon asked the physicist Laplace why God was never mentioned in his great treatise on celestial mechanics, Laplace is said to have replied that he had no need of that hypothesis. The laws of physics had displaced God. Now, this was a new way of looking at the laws of nature. From ancient times, it had been argued, as we've seen, that the lawfulness of nature pointed to a lawgiver. But now it was argued that the laws of nature, in and of themselves, constitute a sufficient explanation for the order of nature. And this does seem to make a certain amount of sense if one thinks about the shapes or patterns that one sees in tangible objects or collections of objects, such as crystals or seashells or sunflowers or the motions of heavenly bodies. Consider, for example, the solar system. It exhibits many striking patterns, 3 of which were discovered by Johannes Kepler. He found that each planet follows an elliptical path, with the sun at one of the foci, with the speed of the planet varying in such a way, it's speeding up as it gets near the sun and slowing down as it gets farther away, in exactly this right way that the path from the sun to the planet sweeps out equal areas in equal times. He also discovered a simple algebraic relation between the period of a planet's orbit and its distance from the sun. All these and many other patterns in the solar system can be explained by the laws of Newtonian physics. In fact, that's what Laplace did. He showed that virtually everything about the behavior of the solar system followed from Newton's laws. That's why he said he had no need of God as a hypothesis. Does that mean, however, that the laws of Newtonian physics explain the existence of cosmic order? No, quite the reverse. For how did Newtonian physics explain the order of the solar system? It did so by appealing to a deeper order throughout the whole universe. It showed that Kepler's 3 laws of planetary motion follow from Newton's more fundamental laws of mechanics and gravity. But Newton's laws describe an order far grander and more impressive than the laws of Kepler. There was more order to explain after Newton than before. And where does the greater order discovered by Newton come from? Newton's law of gravity comes from yet more fundamental laws, namely, among which are the equations of Einstein's theory of gravity. And lo and behold, the mathematical order described by Einstein's laws is even more splendid, beautiful, and profound than the order found by Newton. And the process continues. It is believed by many physicists, by most physicists, that Einstein's laws, in turn, can be derived from yet more beautiful and profound laws, very likely those of so-called superstring theory. This is what the progress of physics, and I've given just one example, but this is what the progress of physics, especially in the 20th century, has shown with ever greater clarity. The deeper we probe into the hidden workings of the physical world, the richer, more intricate, and more magnificent the mathematical structure we find. And we find this beautiful structure in the mathematical laws themselves. All of this has changed the context in which we think about design in nature. When the questions that scientists asked were simply about the shapes or patterns seen in tangible things, however beautiful, it may have seemed naive to to speak of them as fashioned by the hand of God. They could be accounted for by the operation of the laws of physics. But now that the laws of physics themselves have been found to form a magnificent mathematical edifice of great subtlety, harmony, and beauty, the question of a cosmic designer has returned with greater force than ever. In 1931, the great mathematician and physicist Hermann Weyl gave a lecture at Yale University in which he said the following, quote, "Many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult for the knowing person to approach God from history, from the spiritual side of the world, and from morals. For there we encounter the suffering, evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony which is in conformity with sublime reason." Minucius Felix had spoke of the providence, order, and law in the heavens and on earth. The deeper we have penetrated into the structure of the universe, the more order and law we have seen. So that the ancient argument for God from the order of nature has been strengthened, not weakened, by scientific progress. The third development I'll speak of has to do with whether there is purpose in nature. It's easy to regard natural things as having purposes. The sun seems to exist to provide the energy that plants need to grow. And rain seems to exist to provide the water. From this, it seems a short step to ascribing such purposes to a plan existing in the mind of God. And the pre-modern science of Aristotle was based on teleology, the idea that natural processes and entities are directed towards ends or goals, and the objects fall in order to reach the center of the earth. Living things heal from injury in order to reach the goal of bodily health and wholeness. But this teleological approach to science was set aside by the scientific revolution, especially in physics, and replaced by a mechanistic approach. Events were no longer seen as drawn toward future goals, but as driven blindly along by past and present causes. Modern physics explains how the sun formed and generates energy without any reference to ends. In the perspective of modern physics, neither the sun nor its energy are for anything, such as supporting life on Earth. Rather, life on Earth takes advantage of the energy that happens to be there. Darwinian evolution has pushed this mode of explanation further. To put it simply, trees do not exist so that monkeys can climb them, but rather some creatures adapted to the presence of trees by evolving the ability to climb. But the idea of purpose in nature has staged a revival. And again, it is not so much at the level of tangible things, trees or monkeys, and their structure, but at the level of the laws of physics themselves. Over the last 40 years or so, physicists have become increasingly aware that many features of the laws of physics seem arranged just so as to make life possible. These are sometimes called anthropic coincidences. One could give many examples. I'm going to mention just a few. If the world did not obey the principles of quantum mechanics, atoms and molecules would not be stable building blocks with well-defined properties out of which living things would be built. 2, if the so-called down quark were lighter than the up quark, instead of the other way around, then hydrogen, ordinary hydrogen, on which all life depends, would be radioactively unstable. 3, the so-called strong force, one of the 4 known forces of nature, which holds nuclei together, if the so-called strong force were only a small fraction weaker than it is, a crucial nucleus called deuterium could not exist, and the nuclear reactions that power the sun and similar stars would not take place, depriving the Earth of the energy needed for life. And actually, even more terrible is that if deuterium, if the strong force were weaker and deuterium could not exist, none of the heavier elements would be possible, because all the heavier elements get built up gradually from the smaller ones. So in fact, instead of the whole periodic table of elements, we'd only have basically hydrogen. Okay. 4, if the number of extended dimensions of space, the number of big dimensions of space, I'm not talking about the ones that people talk about now, they're subatomic in size, but if the number of extended dimensions of space were not 3, but greater than 3, gravity would act differently, and in such a way that planets could not orbit stably around stars. They would either fly off into space or they would plunge into stars. You need to have 3 or fewer dimensions in order to have stable orbits. If you have fewer than 3 dimensions, other bad things happen. 3 seems to be a very special number of spatial dimensions if you want to have living things. And needless to say, we have 3. The simplest way to explain these and many other entropic coincidences is to say that whoever designed the laws of physics did so with the purpose that life should arise. There's an alternative explanation called the multiverse idea, which I haven't time to explain, but I could talk about it at the Q&A or privately. It would explain some, though not all, of the anthropic coincidences, but it wouldn't dispose of the evidence for purpose in nature. Have very special laws. Thus, one way or another, the laws of physics have to be special if the universe is to have life. The 4th development, and I guess I've reached almost an hour, so I'll just warn you that I only have 3 or 4 more pages. The 4th development I'll discuss has to do with the issue of determinism and free will. For 300 years, all indications were that the mathematical laws of our universe are deterministic. That is, given the state of the universe at one time, the equations would determine its whole future development uniquely, as was famously stated by Laplace 200 years ago. This was a powerful objection to the idea of free will and greatly disturbed religious thinkers. And if anything seemed solidly supported by science 100 years ago, it was physical determinism. But then, to the astonishment, to the shock of physicists, determinism was overthrown by quantum mechanics in the 1920s. For it turned out that a fundamental feature of quantum mechanics is that its equations do not, generally speaking, predict what will happen, but only the relative probabilities of various future outcomes. That has seriously weakened the physics objection to the possibility of free will. To quote Hermann Weyl's same 1931 lecture again, quote, "We may say that there exists a world causally closed and determined by precise laws, but the new insight which modern quantum physics affords opens several ways of reconciling personal freedom with the laws of physics. It would be premature, however, to propose a definite and complete solution of the problem. We must await the further development of science, perhaps for centuries, perhaps for thousands of years, before we can design a true and detailed picture of the interwoven texture of matter, life, and soul. But the old classical determinism of Hobbes and Laplace need not oppress us longer." Unquote. The 5th and last development that I'll discuss has to do with the question of whether the human mind is reducible to matter, as materialists claim. As biological processes have increasingly been understood in terms of chemistry and physics, and as neuroscience has shown how intimate the connection is between mental phenomena and and events in the brain. Many people have become convinced that mind is simply an emergent property of matter. This conviction has been strengthened by the increasing ability of computers to perform tasks that in humans require intelligence, such as playing chess or translating languages. So that man is now seen by many as not having a soul, but as just a machine made of meat, or a wet computer. Machine made of meat is a famous expression of Marvin Minsky, one of the founders of the field of artificial intelligence. However, two very profound 20th century discoveries have cast considerable doubt on the idea that the human mind is but the operation of a physical mechanism. These discoveries are quantum mechanics and Gödel's theorem in mathematics. I can only discuss them very briefly here. So now I'm down to the last 2 minutes. Quantum mechanics, as traditionally understood, distinguishes between physical systems on the one hand and conscious observers of those systems on the other. The reason, they might say, why would a theory of physics make any reference to consciousness? It's just discussing matter. Because physics in quantum mechanics doesn't only talk about the systems being measured, but it talks about the one who does the measurement. The reason, in rough terms, is that quantum mechanics, as I mentioned before, deals in probabilities. Probabilities in this context have to do with what on probabilities. The one who knows or doesn't know the state of a physical system in quantum mechanics is traditionally called the observer. And to know requires a mind with consciousness. So that's the chain of logic. Probabilities involve knowledge, knowledge involves minds. Thus it has been argued, and I won't go through the arguments which are very technical, but it's been argued by some eminent physicists that quantum mechanics implies that mind and consciousness are as fundamental to the constitution of the world as matter is. Heisenberg himself said, for example, that the mathematics of quantum mechanics, quote, represents no longer the behavior of elementary particles, but rather our knowledge of their behavior. And Sir Rudolf Peierls, a leading 20th century physicist, said, quote, the quantum mechanical description is in terms of knowledge, and knowledge requires somebody who knows. He was asked, you mean somebody? Could it be something? And he said, no, somebody. The Nobel Prize-winning physicist, Eugene Wigner, commented that, quote, the very study of the physical world led to the conclusion that the content of the consciousness is an ultimate reality, unquote, by which he meant something as basic as physical things. Moreover, an argument that goes back to the great mathematician John von Neumann says that the mind of the observer is not completely describable by physics within the framework of quantum mechanics. Here is Peierls again. Quote, the premise that you can describe in terms of physics the whole function of a human being, including its knowledge and consciousness, is untenable. That is why Wigner stated that materialism is not, quote, logically consistent with present quantum mechanics. Gödel's theorem was an epoch-making discovery in mathematical logic proved in 1931 by Kurt Gödel, one of the greatest mathematicians of the 20th century. What he showed was that there is more to doing mathematics and to discovering mathematical truth than merely mechanically following rules, the way a computer does, for example. From this, some have argued that the human mind, when thinking mathematically, is not just operating like a machine. Gödel himself rejected the materialist view of the mind, calling it, quote, a prejudice of our time. The philosopher John R. Lucas of Oxford University wrote in 1961, quote, Gödel's theorem seems to me to prove that mechanism is false, that is, that human minds cannot be explained as machines. So also has it seemed to many other people. Almost every mathematical logician I have put the matter to has confessed to similar thoughts, unquote. Lucas developed a careful argument for this conclusion. Since the mid-1980s, this Gödelian argument has been championed and further refined by the eminent mathematician Sir Roger Penrose, also of Oxford University. A point that Lucas and Penrose emphasize is that the human mind is capable of doing something that mere computing machines cannot, namely understanding concepts and grasping meaning. I should make clear that most scientists would be very skeptical of the anti-materialist arguments based on quantum mechanics. And probably today most logicians and mathematicians would be skeptical of this Gödelian argument against mechanism and materialism. Nevertheless, these arguments have been advanced and defended by some of the most brilliant scientific and mathematical minds of the 20th century. One thing, therefore, is clear. Materialism is definitely not a conclusion to which modern science necessarily leads. We see then that the discoveries of the 20th century have shown us a world that looks more like the world of Christian faith than did the science of 100 years ago. We find that the universe probably did have a beginning, after all. We find that the laws of nature have a richness and profundity of mathematical structure that bespeak design. We find in those laws many features that suggest that the universe has a purpose, which is to give rise to life. We find that the determinism that seemed to refute the possibility of free will has been overthrown. And we find that some of the deepest discoveries of physics and mathematics suggest that there is more to the human mind than either physics or mathematics can describe. I've covered a lot of ground, but I hope I've shown that the Catholic Church has been a friend of modern science and has, in turn, nothing to fear from modern science. The real antagonist of religion is not science itself, but scientific materialism, a reductive philosophy that comes from a blinkered view of reality and, indeed, a blinkered view of science and the history of science. Thank you.
Thank you, Dr. Barr. That was very interesting.
Sorry I went a little over.
No worries. So we'll take questions. If you just want to raise your hand, I'll pass you the microphone. Just want to keep your question brief.
The one thing that I and other Catholics or Christians are concerned about, I think, is what I would call the one thing that I'm concerned about in other Christians is what I would call scientific overreach.
Okay.
Science, I think, claims more than what can prove. The Galileo case, I think, is a pretty good example. Galileo claimed that he had proved that the Earth moved around the sun, when in fact he had some evidence that Venus didn't behave like people thought it would, and then the moons of Jupiter went around Jupiter. So he had no proof positive that the Earth moved. Even science today has no proof positive that anything is moving relative to anything else, because we can't view the universe from the outside, so we don't have an absolute reference point. Science cannot positively prove that anything is moving absolutely. Because you can observe.
Question if you have.
Yeah, okay, I'll get to that.
Otherwise, I'm going to have to split my honorarium.
Okay, and for evolution, evolution has also not been positively proved.
Okay. Can I? You've said quite a mouthful. Let me respond.
Okay, so what? My question. Okay, my question was that I was getting to. Why should we alter our belief in the literal interpretation of Genesis, the teachings of all the fathers and?
Galileo actually thought he had two proofs that the Earth moved. One was based on the tides, and one was based on sunspots. It turns out that both proofs were fallacious. So it is correct that he did not have a proof that the Earth moved. And indeed, in his day, such a proof would have been impossible. Real proof that the Earth moves was not possible until after Newton and the and people had an understanding of dynamics, of the relation of force to motion. In fact, it's kind of meaningless if you don't have some understanding of dynamics, the causes of motion. Then actually it becomes, strictly speaking, a meaningless question of what is really moving and not moving. And that actually gets to very deep questions about relativity and what the relativity of motion. But however, what about from the modern point of view? Both in Newtonian physics and in relativity, accelerated motion is an absolute concept. This is interesting. There are many things actually similar about Newton and Einstein's physics. In both Newtonian mechanics and in relativity theory, uniform velocity is a relative concept. So it makes no absolute sense to say, is this object moving? Does it have a non-zero velocity? That's, strictly speaking, a meaningless question. You can only talk about the relative velocity of two things. On the other hand, in both Newtonian physics and in relativity, accelerated motion is an absolute concept. It makes sense to ask of one object, is it accelerating? There's absolutely unequivocal, incontrovertible scientific evidence that the Earth is rotating on its axis. I don't want to get into a debate with you, but I'm just going to assert this as somebody who teaches a graduate course in general relativity, and I know the physics. Okay? It is rotating on its axis. Is the Earth moving around the sun? That's a more tricky question because the Earth is moving according to general relativity. The Earth is well, you could argue that the Earth is not in any absolute sense moving from one point of view. From a local definition of motion, no. From a global definition of motion, yes, it gets very technical. But the Earth is certainly moving, rotating on its axis. I don't want to get embroiled in the discussion of evolution, but there's absolutely massive evidence that of the evolution of species and that of common descent and of the fact that we are genetically related to lower organisms. I'm just going to leave it there. And there's absolutely massive evidence that the Earth and the universe are billions of years old. And if you want to get a good account of what some of that evidence is, go to an address given by Pope Pius XII. No modernist he. An address that he gave in I think it was 1950, it might have been 1951, an address he gave to the Pontifical Academy of Sciences. And in it, he goes through what he calls 4 independent, though converging, lines of evidence from modern science that all point to the fact that the universe is billions of years old. And the lines of argument that he discusses, he was helped in writing this, clearly, since he's not a physicist. He was helped by an eminent British Catholic physicist named Sir Edmund Whittaker. But Pope Pius XII believed that the universe is billions of years old. And if he was going against the teachings of all the fathers and doctors of the church and Catholic dogma, well, we're in trouble. You know, this was the Pope talking. And you can't, as I said, you can't blame him to call him a modernist. I don't think anybody's ever called Pius XII a modernist. Okay, that's, I guess, enough of that. Yeah.
Change the pace a little bit.
Yeah.
You didn't get a chance to talk about multiverses. But, and there are many different possibilities, but I was going to ask you what your opinion is of Lee Smolin's idea of cosmological natural selection, where he tries to do for cosmology what Darwin did.
I don't think it works. I actually haven't studied it, but I know he has this idea of many universes, baby universes, and a certain kind of natural selection takes place where produces more black holes and so on. And so I don't really think that works, but I have to admit I haven't thought much about it. The fundamental argument, as I said, for the existence of God coming from physics, though it doesn't only gets you up to sort of a deistic God, not the full Christian God. But the fundamental argument is the orderliness and lawfulness of nature. And even Lee Smolin's scenario is based upon some fundamental laws. So he's not getting us out of that. As far as the anthropic coincidences, he's attempting, I think, to find some mechanism where universes are sort of driven towards, there's a lot of universes coming into and out of being, and they're sort of naturally driven towards, you're driven to produce universes preferentially which have the conditions that make life possible. I don't think he's convinced many people. I said I haven't really studied that, but I don't see the logical connection between increasing the number of black holes and necessarily having all the things you need in order to have life. Just to take one example, I think it's very important that you have quantum mechanics if you're going to, as opposed to classical physics. He presupposes that there's quantum mechanics. I mean, I don't think he explains away all the anthropic coincidences.
One more question?
I feel like my question is very simplistic then.
Good.
Has any scientist ever tried or attempted to explain the existence or non-existence of the soul?
They tried to explain the existence?
Explain the existence or non-existence of the soul?
In a scientific way?
Yes.
Well, if they did, then I wouldn't listen to them, because it wouldn't be the soul as Catholics understand it.
Okay.
The spiritual soul, not the soul in some Aristotelian sense where plants and animals have souls, but what makes us have spiritual souls, as far as Catholic tradition goes, all the way back to the early fathers, is that we have reason and free will. Those are our spiritual faculties, reason and free will. And those have always been, Catholic theology has always said that those two spiritual faculties are not explicable in material terms. That what is spiritual in us is not reducible to matter. And that is explicitly taught by Vatican II, which says that those powers of men, reason and free will, are not reducible, quote, reducible to the merely material. So if you could explain, quote, something about us from physics or from merely material terms, whatever it is you're explaining, it ain't the spiritual soul.
Thank you, Dr. Barr, and thank you, everybody, for coming. We're going to have, Dr. Barr is going to be selling books, and I'm sure he'll be willing to discuss
And I'm not getting any money out of this.
No.
It's for the seminary.
Thank you all for coming.